So we have 720 grams of glucose, C6H12O6. What we're gonna try to do is convert it to moles. First thing we do is set up our dimensional analysis thing. $720 goes over here. We're converting to moles, so we put in 1 mole over here. And glucose has how many grams? Oh, positive.
Yeah, my
180 grams.
Yeah, it works.
And we put that down here. So what we do next is cancel it like terms. So cross out grams and move everything over. And now we divide 720 by 180, which gives us 4 moles. Speak louder.
Sir, you just nigga before I speak. Trying to remember how to do this. Alright, practice the first 40. That's not analysis. 4, 6, 2. Whoop, 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 whoop. Just give me a countdown. It's ready. Hi, my name's Noel Michael Wardman, and this is our part of this video where we show you how to convert from grams to atoms. Now, it's a very simple procedure once you master the other levels of stoichiometry and dimensional analysis. So this combines them all together. So, in this question, you're given that you have 720 grams of glucose, and you need to find the amount of molecules of glucose does it contain. Well, you need to know 3 simple things. You need to know how to convert the grams to moles, convert moles to atoms, then furthermore, know how many atoms is in a mole. Let me just show you how it looks like when you write it up. So, when you write it up, it'll be a 3-step dimensional analysis, 1, 2, and 3. So you're given 720 grams of glucose. Now, if you pay attention in your chemistry and earlier pieces of this video, you know that glucose is equal to 180 grams per mole. And then lastly, if you pay attention to the part where you convert moles to atoms, you know that every mole contains this many atoms, which is also known as Avogadro's number, which is 6.022 times 10 to the 23rd power. Now, with all of this set up, you can actually start crossing out your common factors. So moles will cancel out when you convert to this, and also grams will cancel out. So your ending factor will be molecules, which is a little too long to write right here. Now here's something you could be a very easier thing to make this type of dimensional analysis really easy. Instead of doing traditional dimensional analysis by multiplying all across and then divide, which delegates to very large numbers, you can just take your time. So, with this one here, we can multiply 720 here and take care of step 1. So over here, we have 720 grams over 180, which simply equals to 4. So in reality, all you have to do is multiply this number by 4, because this is the product of right here. So let's do that. So I'm just erasing this to help you guys keep up with this. So we just found out the first part of dimensional analysis. We went and we converted from moles to grams. From grams to moles. From grams to moles. Now we can do the second step. So we know that we have 4 moles of this. But now we want to know how many atoms we have. So what we're going to simply do is just multiply and divide. Well, we don't have to worry about division because this is already 1. So let's multiply this out. When you multiply 4 by this number, this is what you get. 24.088 times 10 to the 23rd, 10 to the 23rd power. However, you have to note the special exception when it comes to atoms. Whenever you use atoms, you have to convert this to the smallest scientific notation. So in this case, the decimal point needs to be coming over 1. This way there's only one number in the front. So in reality, your answer will come out to be 2.4088 times 10 to the 24th power. The reason why it goes to the 24th power is that the decimal point moves over. So you need to multiply this whole number by an additional 10. And then the way you write out the answer after you complete all of this is simply this number, and you can put molecules of glucose. And simply, you're done. Now, to do this backwards, you just simply flip the script. It's very easy. As long as you grasp the concept of how things work, you can put this all through. Thanks for listening, and enjoy your day.